Constraint formalization for automated assessment of enterprise models. This is a collaborative work of Professor Steph Joosten, me, Dr. Ella Rubtsova, and Elmaki Hadauchi, a Master of Science graduated at the Open University of the Netherlands. In this talk, I will motivate the need of constraint formalization and checks for enterprise models in ArchiMate, explain how a tool ArchiChecker works, present a method for preparation of constraints for assessment of enterprise models, illustrate the proposed method with a case study conducted in a medical center. The results of the case study will be discussed to draw on the future work. An enterprise model is a set of views or submodels. Each view presents a specific part of the modeled enterprise. Each view may be created by a different team member. The ArchiMate specification has been designed for consistent enterprise modeling. ArchiMate defines an internal structure of an enterprise model as a set of views, elements, and relations. Different views may use the same element. Tools give to each element a unique code and check some generic built-in modeling conventions on views. However, each organization defines its own specific policies that may be interpreted as modeling conventions. In order to guarantee a consistent teamwork on an enterprise model, the organization-specific policies have to be formalized for automated checks. In literature, there are not formalized and formalized presentations of constraints in ArchiMate. The not formalized just visualize some access, security, and privacy policies. The formalized presentations use examples of constraints from the ArchiMate specification and transform them into ontology or semantic web. There is a formalization of the meta model of ArchiMate language into the Alloy language to use the MIT Alloy analyzer. There is a scripting plugin, Archi, for formalization. However, the identification of constraints is seen as a real challenge by many authors. This screenshot shows a single view. It has a set of elements, boxes, and relations, lines, picked from a palette, a limited set of elements from the ArchiMate meta model. Each enterprise model has an internal ArchiMate model being a collection of views, elements, and relations, and it is shown at this slide. A constraint can be visualized in ArchiMate. We propose to derive the meta-model elements and relations from the internal ArchiMate model for constraint formalization. The enterprise model and the analyzed constraint are presented in the same meta-model. The analyzed constraint is then formalized in the ampersand language to be used in our tool, ArchiChecker. Tool Archi stores an internal ArchiMate model in the form of an XML file with extension ArchiMate, repo ArchiMate in the figure. Constraints are stored in a file called constraints.adl. Our component, ArchiChecker, parses the ArchiMate model, repo ArchiMate, and the constraint.adl, according to the same meta model. It compiles each constraint into a checking function that can compute violations with respect to that constraint. ArchiChecker emits all violations in the log. This screenshot shows a fragment of the ArchiMate meta model. For example, a relation realization is a pair of an element of type application component and an element of type application function. This slide shows an internal model of an enterprise model in ArchiMate. It is populated with instances of elements. The long numbers are unique keys of elements. In this model, we need to find violations of a given constraint. So we don't transform the meta model of ArchiMate and avoid possible mistakes of such transformations. Identification of organization-specific policies and constraints have been recognized by many authors as a challenge. We have analyzed the documents of a medical center, and in its documents called Project Start Architecture, we have found 10 repeated policies. Our method, aimed to formalize and analyze a given policy, looks as follows. First, reformulate the policy in natural language. Second, visualize the policy in terms of ArchiMate. Third, formulate an expression of the policy in the predicate logic and in ampersand. Run the ArchiChecker on a given ArchiMate view to generate a list of policy violations. Analyze the found violations and the given ArchiMate view to find possible reasons of violations and possible actions. For example, policy 5. Healthcare providers and patients work with one shared file. First, we have to reformulate the policy in natural language. For every patient, there must be one file called patient's file. Each patient must have access to his or her patient file. Each health worker directly involved in medical care for a patient must have access to that patient's file. Others have no access to this file. Second, we need to visualize the policy in ArchiMate. This gives us elements of the meta model for formalization, business actor, business object, and we formalize this access policy using first the predicate logic. We also formalize each constraint in ampersand. For practical use, for communication with architects, we are more interested in a readable form of violations. For this, we add in ampersand a constraint specification, so the ArchiChecker can produce readable sentences. Then we run the ArchiChecker on a given ArchiMate model. A violation of a constraint is a pair of elements expressed in a readable form. For example, patient file is not accessed by a caretaker. This constraint has been checked on the enterprise view CS Pharmacy, shown in this slide. This view presents two information systems used for supply and distribution of medications. The violation patient file is not accessed by a caretaker has been shown to architects. The enterprise architects have acknowledged that they have forgotten to apply this policy. The method has been applied to all 10 policies in 2 ArchiMate views. The first view, CS Pharmacy, the second view, CS Office 3065. It shows the implementation of Office 3065 for collaboration within and outside the organization. The numbers of violations are shown in this table. The violations have been discussed with enterprise architects. Summarizing, we can formulate our contribution. It includes a method for formalizing policies, for modeling conventions and business rules, a rule engine called ArchiChecker for verifying of modeling conventions on enterprise models in ArchiMate. We also have results of testing of the method and the rule engine. As a byproduct of the case study, we found a set of reusable policies constraints. It should be mentioned that the method we propose is relatively labor-consuming because of agreements that have to be made between architects. It also demands accuracy in formalizing. The nice things about the method is that it produces reusable, formalized, and visualized constraints. It also initiates formulating the goals of the enterprise and the goals of policies, and increases the understanding of the analyzed enterprise architecture. Because some policies can't be understood without the goals, our method initiates formulating the goals both for the enterprise and for policies. In future, our method and the rule engine can become a part of an approach for consistent modeling in ArchiMate that includes goal models associated with policies and constraints. Such an approach is our future work. Thank you for your attention, and I look forward to your questions.